Welcome, folks, to another PyMCon session. This is our July session with Max. Before we get started with his talk, I just wanted to say PyMCon is a running web series. You can go to PyMCon.com, which will be linked below the description of this recording, to see all the other talks that have occurred in the past and the future schedule for all the talks that are to come. Next month in our next session, we're going to be focusing on you. So we're going to do a series where we're going to help you with your call for proposals. We're going to be looking for call for proposals in August. You can go to pymcon.com/CFP to submit your own. But I know a couple of you had questions about getting started with proposals, what would be good, whether it's for PyMCon or others. So in August, we're going to help you with your ideas. You're going to see that you'll see that announcement on all the usual channels. It'll be on PyMCon.com. It'll be on the PyMC Discourse. And so I think it's going to be a good time and a casual event for our end of summer. But with that, let's focus back on our event that we have today. We have Max here, who's going to talk about Soccer Factors Model. He has a lot of great content, and I know you're going to have a lot of questions. So for your questions, the best place to post them is on the PyMC Discourse. When you post them there, it means that people can see them for next year and a year on. It's just good to put more knowledge out there on the discourse for folks to be able to reference later. We will take questions from Zoom if folks have questions. But please use the discourse as we'll be prioritizing that. With that, I'm going to pass it off to Max for his talk on soccer factors. Take it away, Max.
Yeah, thanks, Raveen. Thanks a lot, everyone, for joining. Just gonna share my screen here. I also try to dress up in the proper manner, since this is not a job interview. I thought this might be the proper dress code for the soccer factor model. That's the shirt of my favorite team, the Calcio Napoli in Italy. Finally, we won the Scudetto for the third time after 33 years. So big thing this year. But yeah. So hello everyone. Thanks a lot for joining. I'll also have a look at the chat if that's possible. And yeah, for the next 40 minutes, basically, I'll try to introduce the soccer factor model here. I'll first go through a bit of the idea, the theory behind it, theory in air quotes. And then I'll show you how to implement the factor model in code, basically, with PyMC. So yeah, to get things straight first, I want to mention two things. Even though the model carries the name soccer in it, it's not really confined to soccer applications only. So yeah, there are a lot of disciplines out there, team sports, that this factor model might actually be applicable to, like football, American football, baseball, basketball, especially team sport, and maybe even baseball and American football, where data collection is much more evolved than it is in European soccer. The Major League Soccer, I think, is catching up. But yeah, this factor model really relies on huge amounts of data, and then it can really thrive there, I would say. And the other part is that anyone who has expected fancy algorithms here or stuff, I think that's not really the case. The heart of the factor model is yeah, basically the data engineering, the factor creation, the feature engineering, as you wish. I think that's really the heart of the model, and that's the art of creating a proper soccer factor model. So before we go to the code, I want to just introduce the idea and where all this is coming from. And basically, yeah, I think I'm not the only one who is who's sometimes wondering when you watch all these players, especially the goal scorers, when they score a goal and they're celebrating. You're wondering, well, how much is scoring this goal really due to his own skill or ability? And isn't it rather a team effort that allowed him to score the goal? Isn't it maybe the other player that was running at the other side of the pitch and drawing all the attention to himself, allowing the goal scorer to have much more space to score the goal in the end? So yeah, I was always wondering how much is really due to his inherent skill and ability, and how much is really due to the team effort, or also the differences among teams. The player might play for a very, very good team, and the other teams just are not catching up that well with that very good team. Like, for example, Lewandowski a couple of years ago playing for Bayern Munich, and Bayern Munich scoring each game like 3-4 goals. So yeah, how much is really due him is due to his skill and ability, and how much is really due to the differences across teams, basically. So that's the idea behind the factor model. And where does this idea come from? That's really nothing I came up with. It's basically inspired by the asset pricing literature, by finance, by the investment literature, if you want to say it like that. And it's all inspired by French, by their seminal work on factors. And what are factors? Basically, what Fama and French found, or what they introduced, is that there are certain anomalies in the stock market that can basically explain the cross-sectional variation in stock returns. And these certain anomalies are sort of called factors, or they termed it factors. And since then, a huge literature has evolved about factors. What is a factor? A factor in the sense of Fama and French is basically the observation that small firms outperform or have higher expected returns than large firms, for example. That's the size factor. There are many, many other factors out there. If you know these factors, you can exploit this, and you can, in terms of the size factor, you can go long, you can buy small firms and short large firms, for example, and get some excess return from that investment strategy. There are a lot of factors out there, and it culminated, well, not even culminated, but it's still ongoing. There are, I don't know how many hundreds of factors out there in the academic literature. And John Cochrane, a very famous macroeconomist, coined the term the factor zoo in 2011, basically saying that there are so many factors out there that hardly anyone can see through them. And well, how many of these factors really do add marginal value on top of all the others that have already been found in the literature? So this is one stream of basically the idea behind the soccer factor model. The other stream of the literature is kind of combining or taking these factors and then trying to excel the skill of a portfolio manager. And this is the literature down here by Fabozzi, Fama and French themselves, and Berg van Binsbergen, for example. And what the idea behind this model is, they want to understand whether a portfolio manager that manages huge amount of money for clients and receives sometimes exorbitant fees for that, whether these exorbitant fees are justified, whether he has some skill vis-a-vis a benchmark or relative to some known investment strategy. So what these guys are basically doing is trying to explain the portfolio return, the RPT, the portfolio, or the return of a portfolio P of a certain portfolio manager. And what they try to explain it with is, this linear combination here of certain factors, known anomalies. And the idea is that, well, maybe these investors are just investing according to some known factors, according to some known anomalies in the market. But then there's also this alpha here, and this alpha is the intercept, so the systemic part of the portfolio return that cannot be explained by all these other factors here. So this is basically them trying to understand whether the portfolio manager has some skill, and the skill is actually this alpha that should be positive and that should be significantly different from zero. And if there is this alpha, then the portfolio manager has some skill in picking stocks, in selecting stocks, and it's not just following some known some known strategy, some known factor investing strategy, basically. Even though that might also be a skill, so that's also debatable. But basically, that's all the idea behind the soccer factor model. It relies on these two streams of the literature. And how can we think about it in sports analytics, basically? How can we adapt it? And that's actually not a long shot, I would say. So you have up here the idea from the asset pricing literature. And instead of trying to extract returns of a given portfolio, having a continuous variable, you can put there the performance of a player. That could also be a continuous variable. In my application, I just basically try to proxy the performance of a player, whether he scores a goal or does not score a goal in a given game. So basically, we have 0, 1. We have a sequence of Bernoulli trials, basically. And that's basically our target variable. So we try to explain the probability, or we try to estimate the probability of a player scoring or not scoring in a given game. And this translates basically to the following model. So we adapt the model from the asset pricing literature and adapt it into our context, basically. Our target variable is a bunch of 0 and 1s. And what we're trying to, basically the log odds ratio of a player scoring is basically a linear combination of certain factors here, which the certain factors here are X. This is basically the same as the factors from up here, denoted by F. And then also we have basically the skill variable here, the parameter that should tell us the skill of a player, that's the alpha. And that's the log odds ratio, basically transformed into a probability via it's basically a logistic regression via the sigma activation function, actually. That's all what the soccer factor model is about. And one important thing here is maybe to appreciate it, it's really about the factors. And yeah, one important thing is that all these factors are constructed or built on information that is basically lagged. So let's assume that the game is that the referee blows the whistle like at 10 a.m. Eastern time on June the 17th. So then the factors only contain information that is available until 9 a.m. 59 that very day. So it's basically a real time, or the model is constructed or set up in a way that you would predict the probability of a player scoring as if you were in real time, basically. So we're not looking ahead. This is how the factors are constructed. And what are the factors? I mean, I mentioned it in the context of the asset pricing models, but what are the factors in the context of the soccer factor model? Well, it comes down to obviously the data that you have at hand. And I had to rely on publicly available data. But I think it's already a pretty decent data set so that you can construct very interesting stuff here. And here are a couple of variables, a couple of factors. Some of these variables are probably not real factors, so diehard finance people might object. But some of these I think are really factors in a sense of the asset pricing literature. For example, it's the point diff. It's basically the difference of in points between the team that your player of interest is playing for and the opponent's team. So the difference, between the team that your player is playing for and the opponent team that in the next game your player of interest is facing. That's basically one factor, basically, that shall explain the difference in team strength. Another one is basically the goal balance difference. That is basically proxying the goal balance of your current team and the difference to the goal balance of the opposing team. So that shall kind of proxy for, well, how offensive or defensive are the teams, and shall account for that difference in the team strength, basically. So what these factors are actually doing, they shall account for the differences in team strength. So that when we look at the probability of a player scoring, that we have basically accounted for all the differences that comes from the different team strengths, basically, that we're only looking at the skill of a player, basically. So that's the idea all behind it. Yeah. So far the introduction. Maybe Raveen, if there are a couple of questions, I'd be happy to take them before we move on to the next part, which would be to implement the model into code, basically.
I am checking, and I don't see any questions in either Discord or Discourse or the Q&A. But folks, if you have any, go ahead and post them in, because Max is going to ask again at the end, and I'm sure you're going to have someone's going to have something. So Max, okay. Continue on.
Yeah, thanks. Okay, if all that's fine, then we're gonna jump right into it. Yeah, I basically ran the notebook before, so a couple of stuff is already loaded, so that we can save on time here. First of all, I think that's nothing new to you. Everyone who is working with data should have a look at the data at first. Also had to learn that the hard way. No doubts about that. But these are basically the players that we can deal with. Actually don't know how many are in there. Here, maybe some are already kind of famous. I don't know, Mark Hughes, former manager of Newcastle, I guess. So there's some information on the players. Then there's some information on the lineups, on the events. I think events is kind of when was this goal scored, substitutions, yellow card, red card, something like that. It's also somewhere, I guess. Then the games, and a lot of information on the ladder, and then really in real time. That is very important. This is very important, so that we don't get a look ahead bias, basically, into our data. So maybe you can already appreciate here that the data engineering is really the heart of the model, and it's not any fancy sampler or other than that. It's because the model itself, it's yeah, basically a logistic regression, even though a lot of stuff can go wrong there as well. But I think the heart of the model is really the factor model and constructing these factors. Here are a couple of players that I just picked from the whole sample, which might be the most prominent ones. Okay, I see a question coming up. Could I repost the notebook? So yeah, I will definitely do that. So
I'll say
I will repost the notebook.
The notebook is in the Discourse thread. So I'm going to post the Discourse thread here again for you. You'll find everything there. Perfect. Thanks, Raveen. I will also post the solution afterwards, because I don't know if we will get through the two sections. So there will be single player and multiple players. In case you've already seen that, I will definitely go through the single player, and I don't think I will get to the multiple players, but I will point to two or three different sections in there, which might be quite interesting to see, and stimulate some discussion probably potentially. So yeah, these are the players that we can deal with. And then here it comes to the data engineering part. I won't go through the code. I've already loaded it and calculated, but it's basically constructing the factors. One difference also to the academic literature on factors on asset pricing is that these factors have to be tested, whether these are real, like anomalies that you find in the data. I didn't test the factors. I just assumed that they're there, or that they can help explain the probability of the player scoring or not scoring. I just assumed it right away. I didn't check if they're really helpful in explaining or not. So yeah, that's a different thing. But that's just to showcase how the model would work in theory, let's say. So yeah, let's kick it off with a single player model. Here I reposted the equation basically. So we will deal with a single player, and the probability of him scoring is basically
the log odds ratios, or the sigmoid transformation of this linear part here, which is xi, the matrix of our factors of our features, and the loading speeder, and our parameter of real interest, the alpha I, the skill basically of the player. So what do we need? Well, we need our features. What are these features? These are these 6 features here that I've picked. Definitely debatable whether one should be in, whether one should be out. Others, definitely, absolutely. This is just me picking some stuff and also seeing whether I can get some good estimation results. Oh, missing value. Okay, I saw a question popping up. Missing value handling. So the factor creation I did a while ago, but to me there was actually not the problem of a missing value in there. So it was really, everything was in that sense, the data was clean, or overall it was really clean. So there was nothing really missing. And these are the data that I have. It's basically official statistics that you can also come up with yourself when you dig really deep into, I don't know, any website that has the Premier League ladder since 1992. It was kind of a consolidated effort already, and for me it was basically constructing the factors on top of that. So the data collection that I rely on, it's basically available on various public websites, let's say. So it was, yeah, I constructed a factor already on a very consolidated data set. That's it. Yeah, other than that, for sure you had to think about missing values, and yeah, I don't know, maybe if that's really the case, yeah, one has to think about that, that's for sure. So the player we're looking here is Cristiano Ronaldo, maybe the most prominent one. These other factors, we're also going to standardize our data, and yeah, standardization is done here. And then the first task, our first task is basically to put the model to the code, or implement the model into code. And well, what do we need? So I didn't state Bayes' theorem here again. Maybe most of you know that, or it would just be like too much of a repetition for most of you. But the way I would like to think about the data is, or the model is, well, what do we need? Well, we need basically the likelihood. We need to know how the data that we're looking at is distributed, and we need some prior information of the parameters that we're interested in. Or we need to hypothesize what the appropriate prior distribution of our parameters of interest would be. So the way you implement this in PyMC is this container here. And the way I would like to think about, or I try to think about implementing the model is kind of from the bottom up, as it is stated here. So defining the likelihood of the model. How is our Y, our target variable, distributed? Well, it's zeros and ones. It's basically a sequence of Bernoulli trials. So I would say our data is, let's assume the Bernoulli distribution for our likelihood. How is the Bernoulli distribution parameterized? It's by the probability of a successful trial, basically, of succeeding, of scoring. Let's call that the p-score. And then we tell here that PyMC, we tell it that this is basically the likelihood that we observe data that is stored in our Y train. Now, p-score, what is p-score? It's the probability of scoring, basically. But yeah, what is that? How is that measured? When you look up here, the p-score, pi, is basically this transformation of the linear part that is within the sigmoid activation function. And that's exactly how we also implement it here in PyMC. It's basically the linear part that you see here, alpha, plus beta, and the X train where our features are in. And that is thrown into a sigmoid activation function for the machine learning guys out there. And that's basically the deterministic transformation of our linear part here. That gives us kind of the probability of a player scoring. Now, what is missing is alpha and beta. Well, we know our X string, we know our features, we know what they look like, but we don't know the parameters, alpha and beta. These are the parameters of interest. And so according to Bayes' theorem, we have to specify some priors for alpha. How is alpha and beta distributed before we see the data? What would we assume alpha and beta to be? And to be honest, I really don't know. Alpha could actually be anything. It could be like negative, it could be zero, it could be positive. So restricting it really to, one could make one mistake potentially here, is to restrict alpha to a certain domain, like non-negative or so. That might really be maybe not the right way to do, and you might arrive at a solution that you might not hope for, or yeah, don't really want to have as a solution. And the sampler might not work at all. So that could also be a problem. But yeah, I really don't know. I want to really be agnostic about alpha and beta. And that's why I assume, or I specify a normal distribution, standard normal distribution with a mean of 0 and a standard deviation of 1, both for alpha and for beta. One could be much more agnostic, much more flatter prior with a much larger sigma. When I ran the models, it seemed to work okay. Let's say maybe some of you are out there and also did the ran the code and had different specifications, and it worked out much better than mine. Happy to learn about that. That's the specification I chose. And one important thing is here the shape parameter maybe. We will basically have, for each of the features, we have the same prior distribution, but in the end, we will have, for each of the features, obviously different marginal posterior for each of the of our factors, basically, for the beta related to our factors. So that's why here it will be 6 prior distributions, as the length of our factors is 6. The number of our factors is 6. Okay, so that's basically the model. Then we run that, and we can have a look at our model, what it looks like. We have basically in the end we want to arrive at 6 parameters for beta and 1 for our skill parameter alpha. That culminates into the p-score via this deterministic transformation, and yeah, then that's merged with the likelihood. In the end, we have 1,968 observations, and then that's all fine. For now, we know what the prior might look like, but we really want to see what the parameters look like or how they're distributed after seeing the data. And that's where we click the inference button, the famous inference button from PyMC. Basically, we take a bunch of samples from the posterior distribution, and I think that with the NUT sampler, the no U-turn sampler, if I'm correct here. And yeah, we draw 10,000 or 13,000 samples basically from the posterior, but burn in the first 3,000. And yeah, I've already run that just to save some time here. 0 divergences, and to see whether the sampling procedure was really good or performed well or acceptably, we should have a trace that looks like that. So really independent samples, and there should not be really an autocorrelation there. I didn't plot the autocorrelation plot, probably. That's also something one should look at, but since there were no divergences, so really the sample could, could visit apparently the whole posterior distribution. I was happy with these two, these two references for the sampling procedure having worked quite accurately, actually. Yeah, so let's plot to see this Markov chain here. Oh, I see some questions, so let me just run it here. Yeah, so that picture is pretty similar to the one above. That's the posterior distribution of alpha, basically, what it looks like. And that's the trace plot here. Yeah, I'm going to look at some questions. Yeah, hi Carlo. Did you find any difficulties to create the database? What was the most challenging trouble? Yeah. Well, I mean, the first thing was really to see or to find the data. That's definitely for sure. I mean, there's not a lot of stuff out there for free, I guess. Kaggle is, I guess, good address to see there, but the other stuff was really not, or I was really struggling. So most of it is you have to pay for it or so. And yeah, but I think all the teams, they collect so much data and they even pay for data. I think, yeah, there are a couple of databases out there that you have to pay for that are very good, that are a lot of data, and that will be definitely a lot of fun to play around with. That's for sure. Based on which criteria did you make the variable selection for the model? For example, how did you deal with multicollinearity? No, that's for sure. That's a big thing. Multicollinearity, absolutely, and that's definitely something one should look at. I didn't check it for the factors here that I had, or I didn't put it in there. Didn't seem to be a big problem. Also based on how you construct the factors. These are only 6 factors, but when you go further out, for sure you have to take care of that. That's for sure. For me, it's just like picking a bunch of variables that seem to make sense. Also, not to give you the same information basically based on the construction, and then just good to go. But for sure, if you want to implement that more seriously, you have to look at the multicollinearity. Definitely an issue. Yeah. Another question was, would it make sense to have a hierarchy with hyperprior? Oh, very good question. Perhaps some players have very small number of data points. Oh, absolutely. So absolutely. When we go to the multiple player version, then hyperpriors. Even here, hyperpriors would make sense. So definitely that's for sure. For example, the mean or so that you set in hyperprior here for alpha. What you could also do is here we're looking at Cristiano Ronaldo. We're looking at all his games across seasons, but we only have a single skill parameter or skill coefficient, basically. You could, what you will see in the multiple player section, you could differentiate here also across seasons. So to have different skills across seasons, because you might assume there's a lot of seasonality in there, or he might get better over time. So a trend to account for that, definitely. That's for sure. That's a very good point. Yeah, so so far this is just diagnostics. So we stop here. These are the diagnostics where our sampling procedure was well or not. For me, that's all fine. Maybe some some others among you might say, well, you have to take care of this and this. I'm happy to learn about that, but I think for now that looks pretty good. Now what we want to see is to have a look at alpha a bit more in detail. So we're gonna plot the posterior of alpha. This is very easy here via RVs, I guess is the plot. So yeah, this is what the distribution of alpha might look like. Now you see it, well, the mean is negative. And yeah, might be weird in the beginning, but yeah, so to arrive at the probability, you have to do the log odds transformation, so via the sigma activation function. And I don't know what minus 0.77 tells you. I just know that a negative number would actually tell you that the probability of scoring is lower than 0.5. That's all I know. But yeah, let's have a look. But that's for now. Well, the distribution and is around minus 0.77. So it's definitely lower than 0.5, and also here, yeah. the bulk of the distribution, basically. The uncertainty also is rather, when you transform it, then lower than 0.5 for him scoring a goal only based on his ability. So now let's make the transformation. Let's transform it into a real probability here. And what we're only interested in is not his overall probability of him scoring, but really only based on his skill scoring. So what we're going to do, we're going to calculate the mean, let's say. So we're for now looking just at a point estimate. And reasonable point estimate might be the mean, it might be the median. So just to speed things up, it's I already pre-coded that basically. So well, the mean and the median is actually the same of the posterior, so it seems to be quite symmetric. So that's fine. So we don't have any issues further down. Well, issues not really, but it doesn't matter whether we look at the mean or the median. Let's transform this into a probability via the sigmoid activation function. And then what we will get based on the mean or the median is him scoring is a goal is basically, but only based on his skill, on his ability, is 0.32. So 32% of him scoring over is the probability of him scoring in a game based on his ability over the course of his Premier League stay, basically. Now, that's all nice, but I think the beauty of the Bayesian implementation is that you, can really look how confident you are at the credible region around this estimate. And so what we're going to do, we want to maybe look at how certain we are, or that this is really the true skill and ability of him scoring. So let's look at the credible region of 95% as a 95% interval. So we're going to calculate the upper end and the lower end of this. So the 97.5th percentile and the 2.5th percentile of the posterior distribution of our alpha parameter here. Gonna set this through the sigmoid activation function again, and that gives us the numbers that we, with 95% certainty or probability, can be certain that his skill lies within the bounds of him scoring every fourth game, or 25%, and up to 39% scoring in the next game. That's what the soccer factor model would give us here. I think that's pretty interesting. That's good, but overall, that doesn't really tell us whether our model is any good or not. I mean, these are numbers, or as long as we don't know whether our model was really good, whether these numbers are really reliable or not. And a way to do that is to evaluate the model according to several measures. For example, classical regression models would calculate the mean squared error or the root mean squared error. And I think in classification exercises, this is actually nothing else than the Brier score. So just a different name for the mean squared error in regression models with the Brier score in classification exercises. Another metric that I actually like quite a lot is the log probability score, or the log probability loss. It kind of gives you an idea how bold the model is in making predictions. So it gets heavily penalized for making a bold but wrong prediction, and it gets kind of rewarded for a bold but correct prediction. And maybe the most famous one is the area under the curve. The appealing feature of the area under the curve is that it's unit-free, it's scale-free, and it gives you right away an idea of how well your model was. The problem is that it just tells you, it gives you a ranking, or it just tells you whether or how good a model is in finding a random sample that actually is a successful random sample where y is actually 1, whether this would be ranked higher than an unsuccessful sample. It doesn't give you any idea how bold the model is. And in my point of view, sometimes it might be very important to see whether a model can make or has strong conviction in its ability, basically. But nevertheless, for this application, I think the area under the curve is sufficient. It's good enough. It tells us right away how good our model was specified. And an area under the curve of 0 to 5. So it's basically the support of the area under the curves between 0 and 1. 1 would be perfect. Your model would perfectly, basically perfectly predict the outcome. 0.5 is basically not better than a coin flip. So you could, rather than building a fancy model, you could also just flip a coin. So when we look at our model, so the task here was basically to implement the RMSE and the log probability score as a function, because that will come in handy later on. But then what we're going to do now is we are going to not look at alpha itself, but at the whole model that also brings in the factors and the features, the factors and the betas. And PyMC allows then to draw basically from the posterior distribution quite neatly this p-score, because we've already specified it as this deterministic variable, basically. It's deterministic transformation. So it's already scored. It's already stored actually in our trace, and we can get it out here via the trace, basically. And we get 10,000 samples for our p-score. We calculate the mean in this case. One might also calculate the median to the mean in this case. And oh yeah, that's the thing. That's interesting. Oh, good. Okay. Yeah, that's interesting. That's good. I have to run again this cell up here. And now down here again. Should work. Great. So this is what we get for our model trying to explain the probability of scoring for Cristiano Ronaldo. And what we see here, an area under the curve of 71, which is, I think, quite okay, quite decent. Not perfect for sure, but it's also not too bad. So our model actually has some power in trying to explain Cristiano Ronaldo's probability of scoring. Maybe some fancy other stuff with nonlinearities in there could boost it until 0.8 or 0.9 even or so. But we also want to do some interpretation, some inference, right? And not just make a predictive model here. That's the sense of all of that. So our model, I'm okay with that. Maybe some of you guys have already found out a better or have implemented a better version of the model. Happy to discuss that and learn about that. So then I've also plotted here a plot of the time series of our model, what our model would have predicted for each game that Cristiano Ronaldo is playing, and the probability of him scoring is here on the y-axis, and on the x-axis you basically have time. And one important thing to look at here, or to keep in mind, is this is the probability of him scoring based on the whole model, so on his skill and the factors, basically. Not only on his skill, but we're also including the factors here. We're also plotting the factors here. Keep that in mind, because even though I will not go through the multiple players now, I will hint to one or two different things that might be interesting. So here in 2007, 2008, you actually see that his probability of scoring is shooting up. And interestingly, he also got awarded in 2008 the FIFA Player of the Year award. I guess that must have been 2008. So yeah, you definitely see it here. His performance shot up, or the probability of him scoring shot up. So yeah, interesting to see that, to keep that in mind. Now that's it for the single player. Now let's have a look at the multiple players, and there are a few differences. So features, the factors stay the same. I kept them the same. We also standardized the data, but one important thing is here that the model differs a bit. So as said before, we could implement some hyperpriors. That's for sure. What I did here also, I differentiated, indicated earlier, I differentiated across seasons. So there might be some seasonalities in there. Players might perform better over time. To account for that, we will have basically different skill coefficients for different players for different seasons. However, our loadings and the factors, they will stay the same. So they won't carry this season subscript, basically. There will be a single loading for a parameter across seasons, basically, and across players. So they don't carry a subscript I, nor do they carry a subscript F. However, our intercept, that can vary across players and across seasons. Makes it for a much richer model. So here would basically be the implementation of the model. It's actually nothing else or not really different to the model you've seen before. The only difference is really that you have to tell the model a player index, which tells the model at which instances in your factorial matrix each player is located. And then you have a different alpha for different players. And the index is also constructed in a way that there should be different players, or the players also differ by season. So the index tells the model basically at which position there is a given player in a given season. So yeah, that's what the alpha looks like. This is then how you would do the beta, basically, and in the end, you have the same deterministic transformation as you've seen before. And again, the likelihood doesn't change. Yeah, that's basically the only change, that you have sort of a different dimension here, a different index that you have to tell the model. Yeah. Then, for the sake of time, just want to point out a few different things. So this is basically then diagnostic checks for the sampling procedure. Looks colorful and yeah, quite okay, I would say. Then one different thing, or one new thing here, is really this measure of the access skill score. Could have done that also in the single player version, but I just introduced it here. And what the access skill score is basically telling you, it's dividing the probability of scoring based on a player's skill by the probability of him scoring based on the whole model. Basically, in the first place, we would assume that the factors are basically zero, that there's kind of no difference between the teams. And then we divide that by the whole probability, including the factors. And when this statistic here, or this metric S, is larger than zero, it would tell you, well, actually the player is overvalued. Is undervalued, sorry, is undervalued. And basically, based on his ability, he would have a higher probability of scoring than if you also account for his team or the differences across teams that he's playing for. So that's what these S statistics should tell us. Now, if we run that, or if we would run that, we would see this plot here. It's a large plot, and get it on the screen, unfortunately. But again, remember, when this S statistic is larger, then the player would be undervalued. So actually, his team is dragging him down slightly, according to the model. Now, remember that in 2007-8, Cristiano Ronaldo was performing pretty well, or you've seen that upshot in his performance. He also got awarded the FIFA World Player of the Year. But yeah, according to this metric, when you go down, or you have to scroll down quite a lot to find Cristiano Ronaldo in 2007-8. And actually, according to this metric, he would be overvalued slightly, not by much, but slightly. It's 0.96. So according to the model, actually his team was helping him here quite a lot. And when we look at another player, or according to this model, who would actually have been the most undervalued player in 2007 and 2008, well, that would actually be Dimitar Berbatov. Played for Leverkusen, and in 2007 and 2008 actually played for Tottenham, and was signed by Manchester United the year after. So yeah, interesting maybe to see that. So according to the model, this would be it actually. Cristiano Ronaldo slightly overvalued in the year he got awarded FIFA Player of the Year. For sure, it's not about scoring goals only. Definitely, that's for sure. Yeah, and then there are a couple of other plots down there. But yeah, this is just what I wanted to share in the end. Maybe it makes for a nice comparison. And yeah, this is all what the factor model can do, or is intended to do, to really basically account for differences across teams, and to give us a kind of a consolidated measure of a player's skill. Yeah, and for sure, on the left-hand side, on the target variable need not be a player, whether he scores or doesn't score, but could be anything to measure or to proxy players' performance. That's it. Thanks a lot, everyone, and I'm looking forward to any questions that might have come up and for discussion. And yeah, thanks a lot.
We have a couple of questions in the discourse. I will read them out loud. So Tyler says, the motivating idea behind your features basically seems to be establishing the goal scoring with or without a given player, effectively using time with them not on the field as a control, with them on the field as a treatment. If that's correct, does this implicitly assume a defensive team will respond the same way, agnostic of who is on the field? Is there a good way to consider change in the defensive behavior when a certain player is on the field? I could see this as being the case for a superstar, for example. Or do you think that information is contained in the scoring difference?
Oh, that's great. That's a very good question. So definitely, I think that makes a huge difference for sure. If one of the star players is out, then the team will behave completely different. And definitely there's something that you could basically make a different diff here, run that model for sure if he's when he's on the pitch and when he's off the pitch. Definitely, but yeah, it's kind of different to control for that. I mean, well, might not be the cleanest to control for this, but yeah. Also, the point difference or the goal difference, basically, it's difficult. It's really difficult, I would say. One other feature is basically like contrasting the goals scored of the team that your player is playing for, and or the ranking of the opponent team for conceding goals. Maybe that's a cleaner way to account for differences here. But yeah, no, that's actually an interesting idea. I hadn't thought about that. But yeah, thanks a lot for the question. I hope I could answer that. Otherwise, I'd be happy to do that offline anytime. Yeah, very interesting. Thanks.
Of course. I'm personally going to read one more question, Max, and then I'm going to hand it off to my fellow co-planner of PyMCon, Christian. So if you hear another soothing voice that is not mine, don't be alarmed. It is just Christian. Who will be taking this over as I have to drop at the hour. But let me read this last question before I hand it off to both you and Christian. How would you control for skill over time? Basically estimating the aging curve of a player.
Yeah, so the way I thought about it, for sure, I mean, age is definitely, one could control for age in there. So, well, that's the thing. So maybe players get, so the way I thought about evolving skill or deteriorating skill is basically having for each season a different skill parameter, right? That I tried to do implement here in the multiple player part, basically, that you have different skill parameters across seasons, basically. That's how I thought about it. Yeah, because it's potentially a skill of the player that he gets better over time, and others get rather worse over time. That's maybe then the ability of a player to really adapt to his age. Yeah, that's why I try to introduce different alphas across season for each player in the second part. In the first part, that's not accounted for. That's for sure. In the single player version, that's not. That's definitely easily implementable. Yeah, yeah. Thanks. Hope I could answer that.
All right. Another question from Discourse about whether or not the model acknowledges when players are on the team but are not playing. So for instance, a player on the bench influencing the probability of the team scoring. These are, I assume, the sort of intangibles that people refer to.
Mm-hmm. Yeah, interesting. No, so I mean, you could do that for sure. You could maybe include that as another feature, not necessarily maybe as a factor, well, as a factor, yeah, but as a feature, yeah. Yeah, you could introduce that. That's interesting. I didn't think about that. Here for now, that's not. It's only, yeah, I only counted the matches where he was really playing. And I also counted the matches, or I also included the matches where he was, where he came on as a substitute. The problem is I didn't, for example, one should really be fair. And if you got in as a substitute in minute 85 or 90, yeah, one should not include that in the sample potentially, but you don't know. I mean, maybe it's not fair then, but maybe he scores, and yeah, but yeah, maybe not. So so definitely maybe one should take a cut off at minute 60 or something to give him at least like 30 minutes of that. So yeah.
Might be useful if you had a data set where you were tracking players that were, you know, traveling with the team and actually sitting on the bench versus sitting at home or something like that.
True. Yeah. Yeah. No, that's, I have thought about that. That's, yeah. Could enrich it, of course. Mm-hmm. Yeah, it's in the data. It's in the data. That's for sure. I think it's, I think, could not be in the data. Right. Exactly. Could not, it's not, yeah, no, I think, right. Okay.
Yeah. All right. It seems like we plowed through the questions on Discourse. So I will just let everyone who is here know that that we do keep the Discourse post around for posterity. So all the questions that were asked will sort of continue to be there. And if there are follow-up questions that you were unable to think up today but pop into your head, you know, a couple days from now, feel free to hop in there. And we will encourage everyone to sort of monitor that and sort of follow up. So we try and use the Discourse sort of post as the central sort of location for all of the sort of event going ons and links and whatnot. So yeah, so feel free to hit that up in the future. I want to thank our speaker for today. I think that was a great sort of event. Everyone loves sort of the sports stats world. I also want to highlight a couple of upcoming things. So our next PyMCon event is going to actually be led and hosted by Raveen. He is going to be sort of entertaining basically sort of a brainstorming session for future submissions to PyMCon, right? It's a bit meta. So basically anyone in attendance can basically ask questions about submissions, event formats, content, whether things are in or out of scope. You know, I have this thing that I've been working on, would that make a great PyMCon event, these kinds of things. So we are hoping to sort of bring some people out of the woodwork and get them to submit. If you already are confident that you have a tremendous idea for a future PyMCon event, I would encourage you to submit it. The call for proposals is open and we are selecting submissions on a rolling basis, so there is no deadline or anything. So you can submit at any time. That is not who I meant to just everyone. So I just dumped in the pile of links in there. The first link is to the PyMCon website, and on that website you will see the CFP, the call for proposals, at the very top. You can read all about the format. You can see links to past events if you want to get a sense of what is possible, and all the other sort of PyMC links as usual. So be on the lookout for that next event next month in August, I believe. I would hop on the Meetup group, because all of the PyMCon events are pushed through there. And obviously on Discourse, you can get your questions answered as well. So, all right. So thank you again for today's wonderful presentation. And thank you all for attending.